Hello to everyone. When we talk about bitumen facilities, and besides capital costs, there are four aspects we are interested in: energy efficiency, quality preservation, environment protection, work safety. Energy efficiency is one of the most complicated aspects. Efficiency may be calculated by the ratio of the actual energy consumption to permissible theoretical consumption. That is the sum of energy for bitumen heating, heat loss, and energy for transportation, for the current flow sheet individual to each bitumen facility. Total energy consumption consists of the cost associated with product heating, production, equipment heating, and heat loss compensation. There are two types of bitumen facilities. The first ones are facilities where high process temperature is maintained and thermal cycles with the delta of 20 to 30 degrees Celsius are possible. These are supply tanks of asphalt mixing plant, logistic facilities for transshipment from one transportation means onto another. The second ones are seasonal storage terminals and bitumen storages where bitumen is collected in the off-season period and stored for 4 to 10 months with cooling down to the ambient temperature. The cost of heat loss compensation for the first group is from 100 to 90%, and for the facilities of the second group, according to our observations, the heat loss in the total energy consumption starts from 50%. In Russia, the quantity of bitumen passing through such facilities comes up to 1.4 million tons, which is nearly 17% of the total production output. This report focuses on these facilities of road bitumen logistics. The theoretical estimated costs of heating of 1 ton of bitumen with the temperature range from the ambient temperature to the process temperature of 160 degrees Celsius are 92 megacalories, taking into account 20% of heat loss. In actual practice, these costs are within the range from 248 to 346 megacalories. In average, up to 18 megacalories is spent on loading of bitumen to a bitumen facility. It is heating of equipment and compensation of losses during the loading. Actually, the costs are 3 to 4 times higher than the minimum required ones. The increased costs are associated with the growth of heat loss caused by the following reasons. First of all, by the external effects resulting from the difference between the actual demand for the bitumen and equipment performance. External effects are associated with the change in demand for bitumen and the dependence of the asphalt mix output on the speed of preparatory works, weather, etc. The second reason of high energy consumption is insufficient thermal insulation of equipment, tanks, pipelines, fittings. Wrong choice of the heating process mode may also boost energy consumption. The most widely spread technology applied at bitumen terminals is day tanks technology, where separate process units are used for high temperature heating and then work as supply tanks. Almost a quarter of all the heat release surfaces belongs to these tanks and associated equipment. In addition, of units for production of modified bitumens and emulsions, and expansion of the range of stored bitumen makes the terminal system more complicated and reduces flexibility to the change in demand for the product. Extension of the process of bitumen preparation increases the negative impact on the quality of bitumen. Moreover, the growing heat losses from the tank leads to accelerate of aging. Cooling of bitumen at the tank's walls as a result of heat loss causes intensification of convecting motion of bitumen. Oxidation suffers renewal and active vaporization of the product. To decrease the aging rate, it is recommended to use vertical tanks instead of horizontal ones, which have bigger oxygen contact area. The issues of technological process safety for day tanks technology are relevant every day and related to the issues of pumping of bitumen inside the terminal from the storages to the day tanks. These are the issues of possible spillover when filling and overheating when discharging day tanks. Also, there is a risk of seal failure in the discharging manifolds area due to possible pressure growth, especially in the event of insufficient product heating and long-term operations. A large number of pumping operations of the day tanks technology is the reason of heavy impact on environment. In Russia, emissions are calculated by the amount of air displaced during filling of the tank to the environment. It causes strong breathing of the tank, and heating of the product causes inconsiderable breathing. At the day tanks technology terminals, there are at least two strong breathing of a terminal. First, when filling storage tanks, then when pumping bitumen to day tanks. In effect, the strong breathing of a terminal with this technology is equal to the double volume of the tankage. To sum up, the solution to the problem of efficiency improvement, quality preservation, enhancement of safety and sustainability is to cut down heat release surfaces and reduce pumping volume in plant transportation. This approach will also help cut down capital costs of the terminal construction. Self-contained tanks with an option of quick shutdown and start operation is a technological future of bitumen terminals. The new age of eco-friendly terminals calls for the use of efficient internal units. The couple system of the internal heating is an example of such approach. Couple in English means dome because of the shape. The terminal unit makes it possible to carry out two-process operation, preheating and high-temperature heating within the storage tank. Bitumen is discharged straight from the tank onto bitumen tracks or to the process flow. Day tanks and associated equipment such as pumps, fittings, temperature and level sensors, pipelines, beds, etc. are eliminated, thus cutting down capital cost up to 10% as well as terminal area. Heat dissipation area are reduced by 8 to 26% and losses from the internal units become usable. The couple system may be installed on each tank, but also the only one tank used as a day tank and storage tank. We call it working tank. In this case, bitumen is supplied from the other tanks as bitumen runs out of the working tank. This pattern allows up to 70% of bitumen to be supplied by gravity, which ensures both energy saving and reduction of emissions. Two tanks work as communicating vessels without any strong breathing of the tank. Thus, it is possible to cut emissions in half and pretty much avoid the risk of spillover. The surface area of contact of bitumen with air in the internal unit is 5 to 50 times smaller than in day tanks, which ensures decreasing of bitumen agent in proportion to the surface. The energy consumption for loading, storage, and heating of bitumen on one of the first bitumen terminals using the coupled system was 177 kilowatt per ton. As a comparison, our colleagues Amina Tahri and others in their recent research obtained the energy consumption from 101 to 324 kilowatts per ton, depending on the bitumen heating mode. Following the results of their observation, it became clear that the flexible storage mode is the best option from the point of view of both energy consumption and bitumen quality preservation. By the energy efficiency indicator, a bitumen terminal with the coupled system belongs to the A class. The coupled system is the first step on the way to smart bitumen storages with A class energy efficiency, flexible to external effects. Thank you for your attention.